Electrostatics 5. The Coulombs law continued. We just stated it and you are doing few applications. Now I'll continue the discussion further. We have given a formula for the force one charge applies on the other. And we also mentioned that force on a given charge due to many charges will be vector sum of the individual forces the charge would experience because of the presence of other charges. Okay. Now we keep applying this for many questions under Coulombs law. We have done few numerical problems, all right? What do you say?
Yes.
Hello. Now, few more questions. Examples. Under numerical examples rather. See, there are two charges, plus Q here, plus Q here. The distance between them is R. Where should you place a third charge in between them so that it experiences no force? All right. So this very simple question, very obvious, but still we'll show it in a systematic way because that's what you require to do for other questions which are not so direct. Think of having plus Q here, plus Q there. The distance is already mentioned to be R. So think that at a distance X here, you place the third charge. The third charge could be plus or minus. You can see it later. I'll think I have got plus Q here. Now recognize the forces this would experience because of the other two. Put it in a geometrical way, vector way, I mean, show the vector in a geometrical way. This plus Q will repel this. The force is away like that, F1, right? This plus Q also will repel it. So F2. We have been given a condition that the net force is 0. So some F1 minus F2 equals 0, the magnitude. Adding will be difference in magnitudes when the angle is 180. Isn't it so? So what is F1? Instead of writing 9 into 10 to the power 9, you can write K. F1 is because of this I told you. This is repelling it, pushing plus Q away. K, Q by X square. F2 is what? K, Q by
x minus r
minus x whole square. Right. Hope you understood. It's not so difficult. Huh? So k q into q. And remember, when I'm showing vectors directly like this by arrows, then I should write only the magnitudes, and you should not write plus q minus q like that. Showing a vector like this already, you should write only the magnitude. Okay, you should not get a doubt that y plus is removed, or in a different case y minus sign is removed. All that you should not think. So q by x square is equal to q by r minus x whole square. Cancelling. Square root if I take, what do I get? Almost very simple and clear that at exactly midpoint, if we place, that will experience equal repulsive forces and the net force would be 0. And this wouldn't change, this result wouldn't change even if I placed it here, minus q also, in which case this will attract it, that will attract it. So, but the magnitudes are going to be equal, therefore the net force will be still 0. That means exactly at the midpoint, I should place a third charge so that the force on that is 0. Okay. We start with a simple thing there, but now we'll try to elaborate it. Make it quick, but if you have a question, you ask.
Done, sir.
Right. Shall I continue, children? But look, in this problem, we have not mentioned. We have not mentioned whether this 2 plus q's are fixed or free. So will it make a difference in terms of the effect of force on the charges? Are you listening to me? Plus q, we simply have not mentioned anything. Whether they are planted there or they're free. Of course, to find out the force at this instant, the mathematics wouldn't change. But if you would like to know what will happen to the charges as a result of these forces acting, you should really mention the initial conditions. Now, I'll just try to do something like that. 2. I'll try to reduce the writing by giving the picture, but remember, pictures won't be given. You'll be always given words. So you need to picture things on your own. Plus q is fixed. This is also fixed. Okay. Redmi Note 7S. Who could be this? This Redmi Note 7S. Simply quit. Okay. So plus q is fixed. This plus q is fixed. Now, we know that if I place the plus q here, the plus q will be in equilibrium, right? Because we just now in the previous question, we found the net force is 0. This is R.
Yes.
This is R. We placed it at R by 2. So what kind of an equilibrium is this plus q experiencing? Okay, I'll say plus q is in equilibrium, or net force on plus q is 0. We already know that, isn't it? Equals 0. Huh? What equilibrium is this? What equilibrium is this? Stable, unstable. Very simple method of checking stable, unstable qualitatively is this. Say, for example, I've got this box. If I put it like this, a slight displacement will make it fall. If it was like that, this slight displacement, if you do, it can go back. Do you follow? So with a little displacement from the present position you do, if that charged particle is coming back to the initial position, you say it is stable equilibrium. You can convert that into a little more mathematics later. But if you displace it and it doesn't come back and it goes away, further away, then you say it is unstable equilibrium. Do you follow my point? In both the cases, the net force is 0, but I'll show you that kind of a thing happening here. Look at this. I've got plus q there. Okay. Now they are fixed, I told you. I don't know whether you understand the meaning of fixed, but I'll wait for you to say anything. Now plus q here, when I place, the net force on that is 0. Simply displace it along the line slightly. What will happen? Can you tell me, anybody? At this position previously, the net force was 0. If I displace it by some delta x, for example, sideways like this along the line, will the net force be 0?
No, sir.
No. Which force will increase? Force of this will increase, or force of this will increase?
Second one.
Left side.
Second one means this one. This one, I'll say this is 1, this is 2. Initially, this was here, and the net force is 0. I displaced it slightly like this. What will happen to this charge? You tell me. It will come back or further moves in the same direction in which I moved it? Vamshi?
So it will go back.
It will move back because previously at this distance, this force of this are equal. Now when I moved it like this repulsive force will increase. Why? The distance has decreased, isn't it? So it will be pushed back again. Slightly disturb and leave it. Don't hold it. Hello?
Yes.
If I moved it like this, the repulsive force here becomes more, then it will go there, but it won't stop probably. It may go, but it will come back again. So that's what you mean by stable equilibrium. Huh? So you should say that plus q is in stable equilibrium. Stable equilibrium for what do I say? Longitudinal displacements, you can say. Longitudinal displacements. But think of minus q being there, because even minus q would be in equilibrium because the net force would be still 0, which I discussed in the previous example, right? But now what would happen? Let us check. Plus q here, plus q here. Now, if I placed minus q, tell me, Vamshi, again. I moved minus q slightly this side. What will happen to minus q?
So it will again come back.
Come back. Come back with this side. Huh?
Yes.
Yes.
How, Aryan, who is giving the answer?
Sir, the left side.
I
force
moved
will
it
all-
towards right. So what will happen?
So they attract to the second.
See here, they were being attracted equally, children. That's why it is at rest, but not really, not in a stable equilibrium, because if I displace it slightly this side, it will further come this way. Why? The attractive force has increased because the distance has decreased.
decrease.
So for minus q, for longitudinal displacements, it is unstable. But let us check once again. Plus q I put. Now the same old plus q here, the same old plus q here. Let us displace it transversely like this for a while. What would happen? Will it come back or move away further? Look, previously here they were being this was being repelled by the two charges equally. Now I moved it slightly like that. Repulsion, repulsion, there will be further repulsion. So if I displace it like this, it will further move away like that. So this is unstable. Unstable for what? Transverse displacements. But let me come to this minus q here. If I moved it slightly up like that, this would attract, it would come back like this. So for translational displacements, minus q's equilibrium is what? Stable. Whether you all followed.
Sir, where we took plus q in the transverse direction.
Plus q in the transverse direction, the repulsive force would be away.
Yes, sir. Like if we resolve the vectors, then x direction will get cancelled, y direction it will be upwards. So that's why can we say.
Or even otherwise, they're equal forces every time. Law of parallelogram vectors, if you apply, it will be along the diagonal straight away. Anything.
Yes.
It's obvious now. We've done so much of mechanics.
Yes. Sir.
So equilibrium, stable, unstable will be different for different situations. How many situations we discussed? 4. 2 charges plus q minus q. For each of them, whether I displace it along the line or perpendicular to the line. So accordingly, you could talk about the equilibrium. Srikantha, I expect you to come regularly. What happens if you don't come regularly? That is a vicious circle. Because you're not there in the class, you wouldn't follow the next lesson. So every time you'll say, come on, I'm not following. But on the other way, if you make it a habit to come every day, even if it's not very clear, you don't feel threatened and worried. You won't be scared. At least it looks all right. Okay, I've been hearing the same words every day. And slowly something sticks. But not coming at all regularly, all the time the same trouble remains. What's Srikantha?
Yes, sir.
And is not some great serious things. In the beginning, every lesson starts from 0 level. In the beginning, everything is simple. Only later it becomes a little difficult. So until 50% of the time we do a lesson, everybody should be comfortable. That's what we keep doing. We don't think that you already learned something. So it is a very highly systematic and evolutionary and heuristic kind of an approach. So there's no way you don't follow. So tell me, Trishul, are you there?
Yes, sir.
Do you follow all the discussion I've done?
Yes, sir.
Tell me. Others.
Yes,
M.
sir.
Vaishnavi, can I believe that you followed?
Yes, sir, followed.
Really?
Yes, sir.
So shall I continue?
So here we said the charges capital Q are fixed.
Yeah.
If they were
Why did I say
moving,
fixed? Tell me. Because if they're not fixed, the moment I move this plus Q, even the other charges will move, right? Hello?
yes.
So I cannot discuss the equilibrium of this because once again the force changes.
So it will be like totally different throughout the movie.
Another situation that is.
Yes.
I want to discuss the equilibrium of this middle charge. Do you follow?
Yes, sir. The distance will differ. So
That's why I said they are fixed. They are that. First of all, I showed you that when two charges are equal charges are there at some distance from each other, any third charge plus Q minus Q plus 2Q minus 2Q, whatever it is, irrespective of the amount of the charge, irrespective of the nature of the charge, that charge you place at the midpoint of it, exact midpoint of these two, midpoint of the line joining these two, that would be invariably in equilibrium. That means the net force would be 0 on it. But the moment slightly you displace it, you will know whether it is stable, unstable. Very simple. So you are a stable person, for example. So you are calm and cool, but somebody want to test whether it is really cool or not. So somebody irritates you. You might just get a little irritated, but once again you'll gain your what you call equilibrium. You'll be once again becoming calm. So you are stable. But at the slightest of the provocation, you flare up more, you are unstable. So it is almost simple like that. Okay.
yes.
Now.
Sir,
Yes.
sir, in fourth case,
Who is this?
Vamshi.
Vamshi, tell.
Sir, does minus Q charge oscillates vertically?
Yeah. In all these cases, oscillation is happening.
Yes, sir.
It all depends on how much and how you move it. But in all the cases, you can talk of oscillation there. Okay. Because once it comes back, it won't be coming to rest immediately, no?
Yes.
Of course, you can see that it doesn't oscillate if you displace it slowly. Without acceleration, if you displace it, then it will go back and stay there, back again. Hello?
Yes.
Okay, now let me see. Third one. I'll give another one. Plus Q. Plus Q again. They are free. These charges are free. All right. We know that any charge in the middle would be in equilibrium. We know. Do we? We already have shown it, right? We know that any third charge at the midpoint would be in equilibrium. The question is what charge or which charge you should place at this midpoint so that the whole system is in equilibrium. Which charge at the midpoint, which particular charge at the midpoint would keep the whole system in equilibrium. Would keep the whole system in equilibrium. This kind of a discussion about the force and equilibrium is very, very important in terms of the concept, the learning, and important for the exams. So, first of all, tell me whether you understood the question. Tulisvarda,
Sir.
Have you understood the question?
Yes, sir.
Tell me what is that?
So
You
two
understood?
charges are placed free in free space, sir. And we need to place a charge such that the whole system will be in equilibrium.
Previously, how is it different from the previous situation?
So previously it was fixed, sir, but now they are.
Fixed means other. There were other forces acting on the plus q, which were fixed, right?
Yes, sir.
Hello. There were other charges on plus q and plus q because they were fixed. Do you agree?
Yes, sir.
People speak, something interest is happening, right? See, when you're right in front of me, your facial expressions, your feelings will tell whether you're following or not. Now it's all left to your own, maturity of accepting or not accepting that you are following. When I said plus q are fixed, immediately a physics student should think in terms of, oh, if they are fixed, it means they're already what?
Some forces already.
Some other force is acting on them apart from this q by r square, isn't it?
Yes, sir.
Yes.
Like how you may get it actually, if you really want. Come on, sir, you're selling some plus q. How do I get them? Not a big deal. You can have one metal sphere charged and placed on a stand like this with an insulating stand. A small sphere, of course. Another small sphere at some large distance like this. So remember, this is equivalent to point charge here, this is equivalent to point charge here. Fixing means this one. Okay, but what is not fixing? You can place them on a smooth table and think that no friction here. Hello?
Yes, sir.
So they're all very important things. Remember it. Okay, now previously the middle charge was experiencing only electrostatic force, right? But the other two charges were experiencing other forces. Hello?
Yes, sir.
Now none of them experience any other force. None of them experience any other force. Other force means what? Like
by an external.
But now there will be only this electrostatic. So for that, what should I do? Can somebody say something?
For the third sides, I think it will be a negative charge.
Look. This is plus q, this is plus q. Remember, at the midpoint, any charge you place, that will be in equilibrium, definitely, because that will experience no force because of these two, whether they are free or fixed. isn't it?
Yes.
Hello, but now a particular charge here will make the force on this and this as well 0. That's what you mean by saying the system is in equilibrium. Hello?
Yes.
See, if you follow only, I'll take it to the logical end. Though I'm talking problems here, that is a important principle in physics. When you take it to the final state of affairs, you'll have learned some very important idea. So I want your feedback all the time. So a particular charge will make the force on this and this also 0. So let me consider this charge. Consider this. Do you follow? Force on that, if I write this, suppose let me say to begin with, this is also plus q. So this plus q will do what? Repel it. What will this plus q do? Repel it. Right? Call it F1, call it F2. So for the force on this should be to be 0, I should write F1 plus F2 mod F1 plus mod F2 equals to 0 because I showed them in the same direction. So what will be F1, children? For example, this distance is, total distance is R. This will be R by 2. F1 will be K Q into Q by R by 2 whole square, isn't it?
Yes.
As force by this K into Q by R square equals 0. You'll find from here Q equals to minus Q by 4. To understand it, I'll give one more example, after which I'll talk some important idea behind it or about it. Hope people followed.
Yes.
Vamshi, Tulsi, Vaishnavi, Striya. Now, a fourth question I'll put here. First, show that it's obvious there once again, but still I want you to show the maths. Plus Q, plus Q, plus Q a half, all are fixed. Now at the center of the triangle, this is an equilateral triangle. You can put side length A if you want it. Any charge you put there in the middle, the force on that would be 0. So show that force on Q is 0. That Q could be minus or plus. After showing that, we could talk more.
Got it, sir.
Yeah, let others also say something. First of all, you should know how to develop the maths. Simple maths it is, not difficult. Only then I can talk something. So if I go to the next page, can I?
Yes, sir.
Yes.
So what was the figure? We're having something like this, plus Q, plus Q, plus Q a half, So if I placed 1 plus q here, how are the direction of the forces? How are the directions of the forces? This plus q will repel it.
Towards small q.
This plus q also will repel it. That plus q also will repel this. 3 equal forces, equal vectors, or vectors equal in magnitude are making how much angle?
120.
120.
120.
So the resultant will be 0, isn't it so?
Yes.
Yes.
F1,
Yes,
F2, F3. So simply F1 plus F2 plus F3 will be 0. I do not have to tell you again and again about this, right? Huh? Hello?
Yes, sir.
Yes.
But
yes,
now the same question will be changed. Not changed much, you already know what it means. Now this plus q plus q plus q are all free. Give a different number to the question, 4th or 5th, whatever it is. So which third charge at the middle would keep the whole system in equilibrium? Come on. If you did it and give me the answer properly, then I would believe that you understood the whole question. Or if you started trying but you are not able to finish it, then also you tell me. So very reasonable to the extent for those who are trying.
Sir, minus q by 3.
Minus q by 3. Have you done it or just guessing it?
I did it.
No, some mistake is there. Come on, I'm waiting, children. Hello. Hello. No one is saying anything. Huh? Come on. So if suppose I'll do now, you'll copy it without questioning it. I actually, after all these years of teaching, I would really want to know when something is discussed slowly like this, with ideas discussed, all that, what is that you put in your head, or how did you define understanding? I have a real issue with you people there. So whoever wants to do it, tell me what should I do? Come on. I'll give it actually, but that is really not working. I don't know. What are you looking at? Are you looking at, say, this particular question you'll remember? Remember it, I have no problem. That means some arrow, some arrow, some arrow, some 3 arrows symmetrically, something 0. So that kind of a very low level logic, I think you are catching. I say low level logic because logic is also great. I've taught physics to those who are highly logical, were not happy with the physics part of it, but still I made them do something. something great. And later, of course, they became good in physics also. But with you people, I'm not really following. So, Sriya, how did you get q by root 3? On what basis?
I took my vector wrong.
Huh?
Yes, at first I considered one
Okay,
charge.
you took it wrong. Now, after so much time, what's happening? Others?
Is it minus 5q by
Minus
5q
5
q by
q
6?
by 6. No. On what basis? No, instead of telling me the answer, tell me how you proceeded. That's what actually you are keeping keeping a secret for yourself. That's why no improvement is happening.
So we first consider one charge.
This charge you consider. What
Yes.
will this do to this? Repel, because I thought it is minus. So repel C4, if I put it this way, do you have any problem? But should I do that actually? Should I
Or
do
if
that?
we
Because
light,
anyway, the
because
middle charge force was 0. So should I consider one charge here? This charge. Okay, I'll sing the solution, you listen. So this plus q, if I consider, this plus q will repel it. That plus q also will repel it with the same force. So these two forces are k, q into q, q square by a squared, because the distance we thought a. This is also k, q square by a square. The angle is 60. So resultant of these two will be root 3 k q square by a square. But we have not considered the force of this at. That force also will be repulsive, right? Because plus q and plus. So that will be how much? K into
Q capital
q into q by.
A square by root 3.
So a by root 3 whole square. So this plus this equals 0 because this and this are in the same direction. So we'll find q equals minus q by root 3, I think. Check.
Yes, sir, minus Q by root 3.
So those who did not do, could not do, you need to tell me now how you could not do.
Sir, instead of taking minus root 3 k q square by a square, I took it as k q square by a square.
Others? Now I'll be discouraged to talk more about this. Do you know where is our issue going wrong? Tell me. I'll be discouraged to talk more on this. Do you know? If you don't get one question on your own, okay, you did not do. Others, I showed it again. Are you should think, are this I should have done? No, okay, now I understood. Some kind of feeling should come, right? So this is one more question I'll take. What's the point? Huh? There's no feedback from you. I keep telling you all the time now. Like, go to a dentist for filling. They keep drilling. They keep some whatever pin, whatever, put it on, and then it gives a burring sound, and they do something. So somewhere it hurts. You should tell it is hurting. Otherwise, they'll further dig. So if somebody is coming and pinching you hard, you'll say, "Oh no, just wait, I cannot tolerate anymore." So that is the minimum feedback mechanism you need to have. So then we'll know where to stop, how to do, and completely clueless. So I did for 2, I did for 3, but I would like to generalize this whole situation. So there are some finite system of charges like this. Far from anything else. Far from anything else means only these charges are there. No other influence on this, if you think. Hello.
Yes.
Not just 3. There can be many. For example. Hello.
Yes.
You think they are in stationary equilibrium? Will there be in stationary equilibrium? Equilibrium, first of all. Not stationary equilibrium. They are in equilibrium. So is this equilibrium stable? And if it, and that's one question. And what is the interaction energy of such system? So that is an important question, actually speaking. I write my question here in this next page. Let me see. A finite system of point electric charges. A finite system of point electric charges, a finite number, I mean, system of point charges far from any other influences, far from any other influences, is in equilibrium under their mutual force of mutual electric forces. Question 1. Is this stable or unstable? And 2, what is the interaction energy of such system? What is the interaction energy, electrostatic energy, I mean. Energy of such system.
Sir, stable or unstable meaning how will the displacement?
Naturally, that's all.
Sir, but it will be different for longitudinal and transverse.
Tell me.
For longitudinal and for transversal displacement, it will be different.
You can check anything. When the question is open-ended, it means it has been already thought about. So, Vamshis. Hello. So you'll wait for my answer again, right? So I'll tell some very wrong answer, you'll believe it. Hello. And of course, we have not talked about the electrostatic potential energy yet, but it is similar to what we discussed in what? Gravitation. So the formulas will be only replaced in the formulas. The terms are replaced by relevant quantities here.
Or will it be unstable equilibrium?
It may be. So I'll give the answers and I'm not going to explain. This is unstable. 0. So this is the if you want to check, you can check. For example, plus q I have free. Here I had minus q by 4. Huh? So potential energy of the system will be, can I write like this? U equals k into, this is R, this R by 2. K into plus q into minus q by 4. See, for potential energy, you should put the signs.
Yes.
By R by 2. R by 2. Okay.
Yes.
K, Q1, Q2 by R. That's all. Like Gm1, M2 by R minus Gm1, M2 by R in gravitation. Plus K into plus Q into plus Q by what?
R.
R. Then, so this is over. This is over. Is this there still? Hello. For every pair, I told you you should write this pair is over. This pair is over. Should I not take this pair also?
Yes.
Yes, sir. Yes.
So what will be that? Plus K into plus Q into
minus q
minus Q by 4
by R.
by R by 2.
Right.
So is it becoming 0 or not? You tell me.
Yes, sir.
Is it?
Yes, the 2 and 4 gets cancelled. Yes, sir.
Is it becoming 0 or not? In a
0.
similar way, you can check for the other one also. Plus Q, plus Q, plus Q. I told you in the middle, what should I place? Minus Q by root 3 or 2 root 3?
Root 3, sir.
I don't know. So if this is A, if this is A, if this is A, if this is A, this is A by root 3. So many charges have got 6 pairs, I think we'll get, right? Huh? Isn't it 1, 2, 3, 4, 5, 6, right?
Yes.
Yes.
So if you write and add them, see if you get 0. Unstable, for example, how will I tell? If we already have seen here plus Q, for a particular displacement, it was stable because these two are already fixed. If I move it a little that way, it is coming back. But now if I move it this way, when these things will move, so it cannot be in stable equilibrium. So some kind of an explanation I'm given, but we can talk more of that if you people are, listening and understanding. This is an important idea here. That if I've got many charges under the influence of each other, they are in equilibrium. Of course, all of them should be free from any other force. That's very important. So the system will be in unstable equilibrium and the potential energy of the system is 0. So some very big system people give and ask you to find out the energy you need not even do if you knew this idea. So very fattening kind of a combination of charges they might give and ask you to find out the energy. So you can simply say it is 0 if you looked at it properly.
Sir, so this cannot be applied if fixed charges. If fixed charges are there, we cannot apply this.
Yeah. The explanation Well, the discussion can be done for 10 more minutes, actually speaking. But at a minimum, whether you understood this or not, that is important.
Yes.
Yes.
There's a theorem called Earnshaw's theorem. What he said was that under electrostatic force alone, a system in equilibrium cannot be in stable equilibrium. Okay, I'll continue. Hello. No, the arguments are nice arguments we have, but I told you already, unless you people speak, these things cannot be discussed. I was just discussing about force only until now, isn't it? Huh?
Yes.
Just remember all the questions which we have been talking. Huh? Okay, I'll give one more question before it is time. Look, I have two charged balls suspended from the same point through silk threads. They've got equal masses and charges. So they were suspended like that. But they had plus Q on them. Masses are M. Of course, masses can be different. That's it. Separate thing will do. Now, will they be like that? Hello?
Repel each.
Repel each.
They repel. Considering this angle to be theta, to be small, and this length to be L, find out the equilibrium distance. That's another question. So it is the regular dynamics question. You can take one charge there, for example. This one. Draw the free body diagram. Mg, tension, and the repulsive force, right? Hello? It's repulsive force.
Yes.
Yes.
So if this distance was x, if this total distance was x, you could write now this as k q square by x square. If this angle was theta, resolve t cos theta here, t sin theta there. So you get t cos theta minus mg equals 0 in y direction. If I took x and y like this, and t sin theta equals k q square by x square. This is 2, this is 1, for example. 2 by 1 if you do, you get tan theta equals k q square by x square mg. Now, for small angles, tan theta is equal to sin theta. Sin theta is equal to, from the figure, x by 2 by L. L is given. So, x by 2L equals k q square by x square mg.
Sir, x by 2.
Huh?
Nothing.
So, x cube equals k q square 2L by mg. So, x is k q square 2L by mg to the power 1 by 3. This problem can be extended again. In physics, actually, there are no new problems in a particular sense. Everything looks new, but not really new. So actually speaking, if they understand how to set up a question in general, slight variations are not difficult to manage. And they're all standard questions, very standard. Every standard book gives these questions. So if you finished it, I'll close it for today.
Yes. Thank you.
Thank you, Chil.